Welcome to Guide to R for Santa Clara University Economics students. This is tutorial number 4, how to run a regression in R and put the results into a nice table. Here are the learning objectives. You can read those for yourself. And if you need to download the script for this tutorial and or the data, you can go to the website indicated here. Okay, let's get started. So the first thing we need to do is open up our studio and open up the tutorial. The script for this is t4_regbasics.r. That should be in one of the files that you downloaded. And as usual, make sure you go down to the setwd command for the working directory and replace that with the path to your working directory so that you will tell R where to find the data. I'm going to highlight the entire beginning of the script here down through the data section so we can get started on the regression material. And here I've read in the California School District data once again and run the Stargazer command for the data set, which gives me the table of descriptive statistics, which is right here in the console. And you can see, as usual, it's the same data set we've been looking at for a couple of tutorials. And again, if you need a refresher on what the variables mean or where the data set came from, there's a little guide to that in the files that were downloaded with the data. Okay, let's move on to the analysis section and talk about how to run a regression and get a look at the results in R. Before we do that, though, it's always a good idea when you're going to do any kind of regression analysis to plot the data and take a look at the relationships between some of the variables that you're interested in. And this is something we did in tutorial 3, creating a scatter plot of a couple of the variables. And we use this qplot command, and the first variable listed there, the STR, is the student-teacher ratio, and the second variable is the Y variable, the test score, and then we give it the data set, etc. I'm just going to run this so we can remind ourselves what this relationship looks like between class size, that is the student-teacher ratio, and the district test scores. So clicking on that command, we get the plot that's down there in the plots box to the lower right. And again, each dot represents a school district in California, the 420 school districts. And the relationship looks vaguely negative, but we want to fit a regression line and see whether it's negative and how well it's predicting the test score. So to do this, the workhorse function in R is the function LM for linear model. And what we're going to do typically is we're going to put the regression results into a named entity called reg1 in this case, just for regression 1. You could call it what you like. And reg1 is equal to LM of this stuff that's in parentheses. And you can see the structure of this is very simple. The first thing that you put is the dependent or Y variable name. So that's test score. That's our Y variable that we're trying to predict. And then you put a squiggle sign or a tilde. And after that, you put the variable or variables that are going to be your regressors, that is your X variables, the explanatory variables in the regression. In this case, we just have one of those, the student-teacher ratio, STR. Then a comma, and then the data set. So data equals CA school in this case. Now, if I run that line just by itself, you can see that I don't really get any results yet. We have the results are stored up here in the upper right in the workspace under values, reg1. To look at the results, we're going to look at results in a couple of ways. Most of the time we're going to put the results into a table, a regression table, that's formatted in the way that we usually do things in economics. But before we do that, let's just do this command, summary parentheses reg1. So this is the R summary of the regression results. And you may see our regressions reported this way by other people. So let's just take a look at what that does, even though typically we won't be using this way of reporting the results. So I hit run, and let me open this up a little bit. And here is the result down in the console. So what do we have here for the summary? We have this call here that's just telling us what was the regression that we ran, the formula for it. We have some information on residuals. I'm not going to talk about that right now. And down here are the regression coefficients. And in particular, the coefficients are an estimate of the intercept, right, the y-intercept, and that estimate is 698.933. And then here is the estimate of the slope. And R will always tell you the name of the variable, the x variable, and then the estimate of the slope, which is negative 2.2798. So what this is saying is that for these school districts, the regression is suggesting that for an increase of one student per teacher, we have predicted decrease in the test score for the district average test score of about negative 2.28, right? So that's the meaning of the slope. We also have some other information here that I'm not going to go into because we're not typically going to look at this as our way of reporting the regression results. Rather, we're going to use that package Stargazer to put the regression results into a nice table that looks much more like the format that we'll report in economics papers and reports. So here's how it's set up. Stargazer is the command. Again, we put the name of the regression first, right? We put the regression results in reg1, then a comma, then this parameter here, SE equals list parentheses CSE of reg1. Then, comma, we could give the table a title. We give it type equals text, so it'll just print it out for us. df equals false just prevents some degrees of freedom numbers from being put in the table. And digits, how many digits do we want after the decimal point? Now let me say just a little bit, very briefly, about this command, which is rather cryptic looking within the Stargazer. SE equals. As we will discuss in class, in most cases, regression software has a default of providing the homoscedastic assumption standard errors. But those standard errors are not estimated correctly if the data exhibit heteroscedasticity of the error term. And we'll talk about what that means. But what this does is it does a correction for heteroscedasticity. And typically, unless we have some reason to think that there is no heteroscedasticity, we should always do this. Now you'll notice this CSE, and that was, if I scroll back up, I defined this CSE function up here. And that is a lot of coding to just get the corrected standard errors. And we can talk about that in class, how exactly that's working. But at any rate, we want to always have a command like that. So we highlight this whole command, Stargazer, hit run, and looking down here in the console, we have the regression results. We have a table with a title. The column is the results for this regression. The first parameter here, or coefficient, is the estimate of the slope on the student-teacher ratio. Then constant is the same as intercept. So the estimate of the intercept is right here. We have some asterisks that have to do with significance tests of the test, null hypothesis that these coefficients are 0. In parentheses are the estimates of the standard errors of those coefficients. Looking down, we have some other information at the bottom of the table besides the coefficients for the regression. The number of observations, the R squared, which is a measure of goodness of fit, in this case 0.05, which is saying that the student-teacher ratio explains or predicts about 5% of the variation in the test score around its mean. Not a very powerful explanatory variable. Adjusted R squared and some additional materials. And at the bottom, Stargazer conveniently tells us a guide to what those asterisks mean in terms of the significance levels of those coefficients. The following command here allows us to obtain and plot regression residuals. Remember, the residuals are, once you fit the line through the scatter, the actual dots, the data points, are above or below the prediction line, and the residuals are the distance between each data dot and the predicted value from the regression. And we can plot those residuals, and I'm going to skip over that, but we'll talk about that in class. Now, a nice thing about the Stargazer function is that it allows us to put more than one regression into a table. So let's run another regression, and in this case, think about what it's going to be doing. Again, the dependent or y variable here is the test score. There's the squiggle or the tilde, and then after that is the regressor or x variable, in this case EL_PCT, which is the percentage of students who are English language learners in the school district. So this is a measure of kids, the percentage of kids in the school district who might come with certain disadvantages in terms of their test score performance. Now the Stargazer command here, once we run that regression, is going to put both regressions into the same table as an additional column of numbers. So we have reg1, reg2, and now notice the standard error correction here, SE equals. We need to have both of those regressions in here with the CSE function. And they have to be in the same order, notice, reg1, then reg2, as we enter them in the table overall. Okay, so let's highlight reg2 and then the Stargazer. We run this. You'll notice up here in the right-hand side, the values, reg2 has appeared, and here's our table. So here are now two different regressions, column 1 and column 2. They both have the same dependent variable or y variable, but they have different slopes, and the reason, of course, is that the slopes are for different explanatory variables or regressors. Looking down, you can see the estimates of the intercept are slightly different, and you'll notice also the r squared is much bigger for the second regression than the first, which is suggesting that the percentage of English language learners is explaining a lot more of the variation in test scores across districts, or at least allowing us to predict much better than is the class size variable. So that's about it. Running regressions is very straightforward in R, and you can go on and add one more regression and take a look at that with the meal percentage. But I'll leave off at this, and we will continue doing much more with regressions as the quarter goes on.